Now I can see that your brains are already burning after such a condensed presentation that Cosmin has offered. Therefore, I'm going to give you a more relaxed presentation, a more colorful. The research programs on composites started in my university when about 40 years ago we realized that in that part of the country, in northeastern part of Romania, there was a huge need for new jobs. And we decided that the Faculty of Civil Engineering should not be only a center for higher education and civil engineering, but also an important center to develop jobs in civil engineering. And the campus of the faculty has been thought and designed. It consists of 10 buildings with different facilities and is organized in 6 departments. It offers 4 undergraduate training programs and 10 Master of Science programs. We have now 2,500 undergrad students, and you can see a quarter of these are master students and then PhD students. To develop any program in civil engineering and with good results in experimental work, we have developed a number of new laboratories or upgraded the existing ones. There are some unique infrastructure pieces, such as an earthquake research station, accelerating low station, and then a wind tunnel, and also a laboratory for composite and structural strengthening. We have added lately a climatic chamber to study the phenomenon of heat and mass transfer through all elements. The infrared thermography completes the existing infrastructure for research. The research area, and now why composites in civil engineering? Why composites, since we have so good traditional materials such as steel, concrete, timber, masonry, aluminum, or other like this? Because there are some issues that cannot be solved solely by simple materials that we are using. Don't worry, there is still room enough for all other materials, because the composites in civil engineering do not occupy more than 2.5% of the volume of the production. 2.5%. The composites are materials or systems that are made of 2 or more faces separated by an interface and with the properties that are better than any of the constituents provide working individually. A modern definition of the composite materials provides that the fiber volume fraction or the reinforcing fraction should be at least 10%, and the ratio of the properties should be at least 5. The main characteristics and advantages that promoted composites are the lightweight and the controlled anisotropy. Especially this controlled anisotropy gives us a lot of difficulties in understanding, because the students like the idea of controlled anisotropy, but they dislike the idea of using equations that characterize anisotropic materials. Some achievements related to corrosion behavior and the very active involvement of reinforcing bars in bridge decks in Canada and United States, where the use of salt in de-icing during the severe times promoted a very high rate of corrosion, and this has become a huge market for engineers in Canada and in United States. As a matter of fact, Canada is the country that has developed the best network of excellence for promoting composite. It's ISIS Canada, a project that was involving about 40 million Canadian dollars, and many very good papers and norms, design norms, have been elaborated by that team. The electrical non-conductivity and also the electromagnetic transparency are qualities that have imposed composites as material of choice. I remember that in 1995, when I was in the United States as a Fulbright scholar, the American Broadcasting Company, who has owned at that time the transmission rights for the Olympic Games in Atlanta, Georgia, 1996, had to construct their headquarters on a bank in Atlanta, Georgia, and they have chosen to select pultruded shapes to construct the shelter for their devices. Also, the formability of the material is amazing, and on the left side we can see an exhibition of United States in the Soviet Union, but on the right side is one of the good achievements of my faculty, of our team, in designing, constructing, and installing the double curved shelves. This is what you remember, the Munich Stadium, and this is a composition of products which reminds me of a conference that I attended in 1972. It was the Second World Conference on Reinforced Plastics, and it was a hot debate between Christophe Chamez, he was the head of the Division of Structures in NASA, and Professor Salmon from Wisconsin University, when a producer, Morrison Mulder Fiberglass Corporation, the producer of these shapes, they discussed about the efficiency of composite shapes. And of course, the efficiency of composite shapes do not duplicate the shapes in steel. But the producer said it was a double shock for the users to have an entirely new material, an entirely new element, an entirely new system of joining, and new structure. That was too much for constructors to absorb at the same time. So they decided to use the new material with less properties, but to keep the engineer familiar with the existing shapes in structural steel. I think it was a wise decision because the market was declining at that time, and then it increased a lot. The light transmission and transparency, again, on the left side is our own multi-folded skylight, and on the right is a control tower in New York. Now you can see that if you are honest with any material, after praising it and exposing only the advantages, you have to be correct, and you have to have a critical evaluation. Now, in a critical evaluation, you have to keep in mind all these drawbacks or disadvantages that composite might have if you don't use them carefully. It is first a brittle material, and then a number of properties that we are not very familiar with. The first European project that we have been involved in relation to new structures made of concrete and reinforced with composite bars was a project in which we had to initiate the production of curved elements. And we developed a spiral in our faculty that was for a few years produced by a company in the city of Iași. There are many other difficulties in understanding composites. For instance, it's very complicated to determine how the composites fail in compression. Then, if we normally use 3 or 4 parameters to design structures made of isotropic materials, when we deal with composites, we need at least 5 stiffness properties and at least 5 strength characteristics. Not to say that the elastic modulus has a strain variation with orientation of load with respect to fiber reinforcement, or the thermal conductivity or thermal expansion is very different from what we are familiar with. Now, what happens to composites in my faculty? In a faculty in Romania, I'm going to say it in Romanian because it doesn't have a very nice translation in English. It is said, "Spune-mi cum arată planul ca să zic cine e decanul." It's about the curriculum in civil engineering, and since I became head of the Department of Civil Engineering, I was able to promote a special topic about the composites in civil engineering. Until then, it was not possible. Everything was completely still. Of course, strength of materials, theory of elasticity, and structural analysis. Now, what's the content of this topic in my faculty now? As you can see, it starts from the primary or basic knowledge with constituents, but it starts with the SWOT analysis. At the beginning, I was only telling about the advantages. Now, when I start talking the subject, I make a SWOT analysis from the beginning, because I think it's fair. It's fair to say what is good and what is not recommended to do with composites. Then I go to micromechanics and macromechanics, sandwich and laminated structures. Then I go to the possibility to reinforce concrete elements with reinforcing bars. And the newest topics, starting from 81, 91 in Europe, then Japan, United States, are the strengthening of civil engineering structures made of traditional materials. The newest topics that we are developing now in our courses, because there are 2 courses in composites. One is for undergraduate courses, and it is taught in the 2nd semester of the 4th year of study, and the other one is given as a master course for students that are studying also advanced techniques in structural strengthening. In addition, we also deal with hybrid structures made of composite materials and traditional materials, and the newest topics, which is a subject for the youngest PhD student coming under my supervision, is about life extension of civil engineering structures using composites. It also deals with life assessment, life cycle assessment, life cycle cost. And finally, a number of miscellaneous applications. Well, and now I'm going to cover very quickly the main topics that we developed in our faculty. Before 1990, the industry of Romania, the chemical industry of Romania, had enough potential to develop at least one type of composite materials. It was glass reinforced polyester. We had a polyester fabric in Bucharest, a fabric for fibers and for inhibitors and accelerators, and 2 major fabrics in Iași. So at the beginning, we had to develop a number of multi-folded structures for skylights in the developing industry in the corrosive area around Iași. Here is another development of shell roof elements, and on the right down, you can see a vandal desk. Another very peculiar story happened in 1988 when former President of Romania, Nicolae Taranu, intended to visit the city of Focșani. Focșani is a very active area from seismic point of view. The city hall had a special skylight which was supposed to be made of glass. We didn't have any other materials at the time. We didn't have any products from import. And the president was afraid that an earthquake might happen and he would visit that primary, that city hall. So the local authorities decided to replace the steel skylight with another one which don't endanger the life of our distinguished guests. So we had 6 days to design, fabricate, and install a 100 square meter skylight, which was, you can see on the right, up, down, up and down. Down you can see this skylight. We said, okay, we are going to construct the skylight. But when the visit finishes, take it out. It's still there. And it looks like there on the right side. But how the history is written sometimes in the start. Another topic that was started in my faculty was sandwich elements. It was the time when our company was expanded with works in different countries from the Middle East, and we had to coordinate the effort of a factory that was producing sandwich elements, Rompan 1, Rompan 2, that were exported at the time. And it's part of my PhD thesis also, when I managed to have a number of brevets for the testing. In 2002, we have been asked by some partners from Europe to develop this kind of bent elements to reinforce the columns for power transmission lines. And this product was developed by Seproplast, is a research center in Iași, and then it was produced for a short time, and then was sold for, I would say, funny reasons. To see how the failure of composites is, have a look at that picture and compare with the entire failure of steel. A number of research projects have been dedicated to properties, but then the strengthening techniques came, and we have been involved from the very beginning, along with our colleagues from the University of Sheffield, where we have a good exchange teaching and research program. The plate bonding technology, a beam that has been strengthened with a plate attached to the tension side. Look how the failure happened, and this is when we first tried the plate bonding. Then we had to improve the shear strengthening, and then you can see that we have a real civilized failure now. And the professor of structures made of reinforced concrete, they know that if you have a rigorous civilized behavior of reinforced concrete beam, you have to have a yielding reinforcing bar steel and a compressive failure of concrete. And here is the whole philosophy of strengthening the reinforced concrete beams with attached plates made of fiber reinforced polymer composites. We extended our research with plate strengthening, and a very recent PhD thesis was dealing with it. And then we went to confining. What's the difference in philosophy of strengthening? In case of beams, we want to supplement the reinforcing bars existing already that have been eventually damaged by corrosion, while in confining, we want the concrete to work better. And you can see that the stress-strain curve in case of confined concrete improves a lot. The effect of column strengthening to confining, a number of 3 PhD theses have been dedicated to this subject, with the columns, circular columns, square columns loaded axially and loaded eccentrically, until we define the interaction formula. Another topic was the bonding CFRP concrete. We were part with Professor Balash in a European network, Marie Curie Research Training Network, and one of the goals was to develop a round-robin test. On the round-robin test, meaning tests in different laboratories on the same topic, and we have been involved in this topic with Sheffield, with other partners, all partners from 11 countries in Europe. Part of the technology, the young lady who is on the corner, she was the PhD student for the topic, and here are some details of the failure. And finally, the shear stress average length diagrams. Then another of my colleagues decided to work on strengthening masonry arches and masonry walls. It was related to traditional architecture in northern Moldavia, which we believed we could provide the help. And here is the masonry bolt loaded on the platform. And finally, you can see the failure of that important structural member for traditional Moldavian architecture. The strengthening of timber beams has been the topic of another PhD thesis. Here are some solutions, the technology, the effect of strengthening. Then a German guy came from Constance and he wanted to study the effect of strengthening the ends against shear failure. And we decided to extend the polymeric matrix to mineral matrices. And Professor Cosmin was member of the defense committee that evaluated that thesis not, I think, about 1 week ago. So the mineral matrices were intended not only to attract new materials, but also to introduce the idea of ecological materials. Also the interface with fibers, the penetration of this type of mortars, results of elements made of these materials, and the modification of the existing calculation formulas for multi-layered composite structures. Of course, we had to write a number of books on this topic. So you can see here 7 books that have been published on the topic. And finally, these are our ideas about the future research, and they are coordinated with our friends from a new project that has been submitted to the European Union. It's a COST project, involving 17 countries, 17 European countries, and 8 countries non-European, from the United States, Australia, and Asia, that seem to be interested in developing this subject. And now, this is a review of what we have done in composites since the very beginning, 1968, when we made the first composite elements. Okay, and finally, this is the real conclusion. I was in Ottawa last year, and I gave a lecture on composites at the Faculty of Civil Engineering. When I went home to Montreal, where my family lives, with that daughter that was testing against vandalism. And this is my youngest grandson asking me, "Aren't you fed up with these composites? And if so, why don't you come and do babysitter with me?" And this concludes my presentation. Thank you.